Hi everyone, welcome to the part 2 of control flow and composite types video. In the previous video I showed you guys the control flow, if statements and the switch statements, and we also talked about the array composite type. And in this video we're going to start off with slices. So a slice is a lightweight structure that just represents a portion of an array. So fundamentally a slice is an array in Go. Okay, so it's just a bit more flexible type of an array. All right. I told you guys that you cannot really extend the length of an array once you've created it, but with slices that is possible for you to do. And there is a way that arrays are treated in Go that actually makes them really a bit rigid. Okay, so for example, if you have an array that contains 2, 3 and 4, and this array is obviously of length 3. Okay, let's make that 4. And an array that has just 4 elements is basically a bit easier to copy over. So let's say we want to just get copy all of these elements into another position. It's very easy to copy it over. Or let's say that we maybe want to remove this particular element from this array. Okay, so initially you know that the first element, element 2, number 2 is of index 0, 3 is of index 1, and 4 is of index 2, and 5 is of index 3. Okay, so if we go ahead and maybe delete this, we should expect that number 5 we shifted, the index of number 5 will shifted down to number 3. All right, so I mean this is just one, we just had to shift one number, which is 5, and that is fairly fast and easy to do. But let's imagine that we have millions of let's say we have 1 from number 2 up to, let's say, something like 1 billion. Okay, or let's say 1 million. I mean this is a lot of data, and so you can imagine if we come and removed the second index, which is number 4, from the array, we'll expect the computer to shift every element on the right by less than 1. So as 5 I had an index of 3, as you can see, it becomes 2, and 6 that was here, probably it had an index of 4, it now becomes 3. Let me write it out so this thing is a bit clear for you to understand. So let's take this thing back to the way it was. So let's have a 7, 2, 7 is of index 5. Okay, so and so on. Okay, so on. So let's say that we want to remove number 4 from the array. If we go ahead and remove number 4, we should expect that number 5 now becomes of index 2. Okay, so for that to happen, we have to shift every element on the right by 1, shift it to the left. So I mean this is memory. You expect the compiler or your operating system to actually go through all of these numbers and change the index to 1, and so that everything is doesn't have a weird behavior. That's what we expect to happen, and that's what will happen. Okay, but this operation can really be expensive, so you can imagine something like this. Go is known to be very efficient and fast, and that's why arrays are probably made to be that rigid. Okay, but we have something that is a bit simpler. All right, and those are that is a slice. Okay, so a slice is a lightweight array, like I've said, but a slice doesn't necessarily contain all of the elements of an array. Rather, it points to an array that exists somewhere on your computer memory. Okay, so if we were to create a slice of an array, this array on line 20, we expect to have our slice look something like this. We have a pointer, have the length, and have a capacity. Okay, so yeah, like I showed you in a previous video, I showed you how we can use the length function and the cap function to retrieve the values of the capacity and length of an array, for and every array of course has a length attribute and a capacity attribute. All right, so what your slice does is your slice has a pointer. So a pointer, we are, by the way, we're going to talk about pointers very soon. I think it's going to be in this video, so just don't worry too much if you don't know what pointers are. But you can think of pointers as an address to a location. Okay, so if you have an address to a house, maybe your own house, that is a pointer for somebody. So if you give a stranger your address, that is like telling the person how to access where you live. So that is what a pointer is. So a pointer is basically an address to where a particular value lives in the memory of your computer. Okay, so what a slice does is a slice has a pointer to the first element of the underlying array. Okay, so a slice of the array on line 20 is defined. Let's assume that it's defined on line 21. Okay, so it's going to contain the pointer to the number 2. Okay, so this is just this, it probably will not literally be number 2, but it will be an address to where 2 is actually saved in your memory. So maybe inside the array where the address of 2, that's where it's going to point to. And then the length, which is basically going to be the length of this array. Okay, and then the capacity, which again is going to be the capacity of the existing array. Don't worry about this, I'm going to use examples to explain more. Okay, so let me open a diagram that I already have here on my browser. So as you can see, so a slice is the description of an array segment. So let's assume that this is our array, okay, and we created a slice of our array, all right, of this array. So the slice just points to the first element here, so that's the address of the first element, and then the length, which is, as you can see, 1 2 3 4 and 5, and the capacity. So this array is expected to contain only 5 characters, or just 5 elements within it. So a slice just basically bootstrapped all of this. So as you can see now, the benefits of just having a pointer is that you can easily change the location of a pointer. So let's say we want to remove the first element of this array. Now we don't need to do all of that operation of doing anything, all of those things. We can easily just change the pointer where this guy is pointing to, and then point it to here, and everything should still work fine. All right, so we're going to do a couple of operations to see how all of these things really works. Okay, all right, so let me quickly open up my main.go, and so we have an array of strings, by the way, and it has a length of 7 and of course the capacity of 7. By default, that is what all your arrays, the length of an array becomes the capacity. Okay, so like this, we cannot really affect the capacity or the length of an array unless we declare it. Okay, but with slices we can have control over that, and I'll show you how to do it. All right, so let's say that we want to create a slice of let's say we want to create a slice of elements from this existing array. So to do that, we can we'll go ahead and create a new variable. Let's call it ladyvala, and we declare and initialize it to this. Now I want to create a new slice starting from this element here, okay, which should be of index 0 1 2 3, of index 3 up to the end of the array, which is of index 6. Okay, so if we do that, we'll specify the starting point. All right, so this is where we want our slice to point to as the first element of our slice. All right, so we're going to specify it as the number 3 to the end of our to the end of the existing array, which has an index of 6. Okay, but by default, if we use number 6 here, the last element will not be included. Okay, so there was actually a problem that caused the code engineers to actually make it that if you that the second number in your array slice, like the index that owns the second number, will not be included. Okay, so this is, I think it's because of the negative sign stuff and things, so that you wouldn't have things like -1 appearing here, and that is not possible. So that's why the decision was made that to get the last element, we have to either use the number 7, which is basically beyond the element. So this is of index 6. So if we want to include this, we have to either add a higher number as the ending index, or we omit it entirely, and that should print out everything. So let's go ahead and print that out to the console. So to do that, go ahead and run, and as you can see, our array slice has been created. All right, so just for to show you what is actually happening here. So now if we check the capacity of this lady var, it should be of 4. I think it's 4. Yeah, I think it should be 4 3. Yes, 4. Okay, so that's the capacity, and the length is obviously the same thing, and nothing. We can't really extend this array, or, I mean, we can't really extend the capacity the way it looks like now, unless we use another inbuilt function called the make function. Okay, so the make function is used to create can be used to create slices of different types. Okay, and we can do that by so let's go ahead and make. We want to create a slice of strings, and it's going to, so it takes 3 parameters. The first is the type, okay, followed by the length, and let's say we want it to be of length 5, okay, and a capacity of 7. Okay, so now this capacity parameter is not mandatory. We can omit it, and by default our capacity becomes 5. So our slice will have a length of 5 and a capacity of 7. Okay, I hope that's clear. So okay, so we can go ahead and do this, and then we can copy over what we already have in our existing array into this new slice, and we can go ahead and copy it by, we use the slice operation, and we want to slice from the first element, okay, which is 0, and because we want to start from the first one, we don't need to add 0. You can just omit it and it to start from the very first element here, and we want it to stop at the 5th element, which is the varda, and to do that we used the index of 6, so the last element will be added. So I'm go ahead and run this, and as you can see, the capacity, okay, the length gets printed, and yeah, we can print out all of the values. Okay, now so let's try and add something, like let's try and add more than 5 elements to this our array slice, and see what the compiler will do. So if I run this, you see it still works. Okay, so now this is the fun thing about using array slices. All right, we cannot really do this if we're using arrays. So slices are really flexible, so given that we can easily extend the length of our arrays and the capacity. So right now that we've added this, let me try and print the capacity, and as you can see, it's very dynamic, and it has increased on its own. So it behaves a bit more like other, like how other programming languages treat arrays. So yeah, it's much more flexible. Okay, so now there's another function that I want to introduce to you guys, and a very easy way to actually do something. That you can actually use the capacity function here, and it should generally give us the same thing, so which is 7. Yeah, everything still works well. Yeah, everything still works fine. Okay, so yeah, so that's it about creating array slices using the make function. There is another way that we could actually add values in our existing lady var slice. Okay, so we can use the append function. So the append function also returns a brand new array slice. It doesn't copy anything over. Okay, it just creates a new slice, and then does basically the same thing that I explained earlier, where I told you that the slice just contains the pointer to an underlying array, and does all that. Okay, so we want to append okay, so I think we'll have to declare this first. So let's see, var lady var, which should be an array of string, sorry, slice of strings, and can go ahead and say lady var, so append, so we can go ahead and copy everything in vala into the lady var. So for now we can just go ahead and copy everything, and this append does not take a string as second parameter. It has to be a single value. Okay, so we, instead of typing something like this, say manway, and Ulmo and so on, we can actually use what we call a spread. I think in JavaScript it's called a spread. So we can go ahead and just spread this in here, and okay, so we're actually not allowed to spread our Valar array, okay, but we can create a dynamic slice, which oh no, this should be on the right, sorry. Yes, that was the issue. Let's see, type of string. So yeah, so let's, yeah, as I was saying before, so we can dynamically create a slice from the existing string. So this just copies everything, so it just creates a string slice, sorry, an array slice with all the elements that exist inside our Valar array. So as you can see, if we do not use the slice, this is not going to work. If I try to run this, it's going to complain, because arrays are quite rigid and cannot really do that operation here. So but we can create a slice, dynamically create a slice from the existing array, and this should work fine. And if we run that, everything gets copied over. So let's say we just want to copy a portion of this, of the existing array. We can specify with the starting index. So let's say the index is 4, and we want to get till the end of the, okay, let's say we just want to get 2 elements, so we can add 6 there, and when we run that, and oh, that actually give us 3, so 3, 4, and 5. So that's the indexes that will be copied over to our new slice. So yeah, so slices are quite flexible, and you find out that we'll use more of it instead of the more rigid array types. Okay, so before moving on to the next topic, you should also know that an array slice is just like every other array, can be indexed into. So we can still access the elements of our arrays using indexes. So we can use this to print out the so remember that we basically copied part of the var in here, so expect that this is something that looks like this string and just contains a part of it. So start from the third index, which is from here. No. Yeah, so it starts from here and copies 3 elements, and yeah, so this is what lady var represents, and that's why when we try to get the first element, the first and the second elements with index of 1, it prints out varda. So yeah, so that is we can index into our array slices. So basically any operation that you can do on arrays can be done on your array slice. Okay, I think that's that for this, and hopefully when we write more programs you can see some other applications of array slices. Okay, so let me get rid of this. We'll move on to let me handle this. Bring this in here. Yeah. So let's move on to next. So we're going to talk about maps. Okay. So maps are basically what we call a hash table in a language like Java, and dictionaries in a language like Python. So maps are just key value pairs. Okay, so what I mean by key value pairs is they are just like arrays. All right, but now you can name the index. Okay, so if this was an array, the first element will have an index of 0, right, and maybe say 1, and the second element will have an index of 1. Okay, and say 2 here, and this is how arrays work. Okay, yeah, remember when we try to index into this, and it just gives us index as the key to access these elements. But in maps are different, in that you have the ability to name your elements. So we can actually name this 1 and name this as A2. Okay, so this is it. That's just difference. Okay, so they are much more flexible in that when you want to find something inside a list of maybe a list of numbers or a list of names, you don't have to look through everything to check what you are looking for. You can easily use the key of the element to access it. All right, so notice how I use the strings here. So I think in Go it's actually very required that your keys are string based. Okay, so yeah, so let's go ahead and create a map. Okay, so I am going to hold on. Okay, so let's create a map. So we can declare a variable. Let's call it clans. Okay, so it's going to be a type of map. Okay, so we use to create a map, use the keyword map followed by the type. Okay, so the key type. All right, so we expect the key type to be a string, and then the value must be of type, let's say string. Okay, so I think it's actually possible to let me just first of all print this out to the console and call it clans. Okay, so looking at it again, I think it's actually possible to have ints as keys in Go. Yeah, which is lovely. Yeah, so yeah, thinking about it now, hash tables, that's where the name actually came from. The keys are actually generated by a hash algorithms that makes sure that there is no clash in keys, so you cannot use the same key for different elements in a hash table. that's going to create a conflict. Okay, so it's possible to use an integer. So you can actually try this out. I've not tried it before, so maybe try using an integer as your key and let's see how that goes. But yeah, so so let's talk about maps. So we've declared the map, and by default Go will initialize this with the 0 value of maps, which is a nil. So if we go ahead and run this code, we should return an empty map. Okay, so now to add an element or to add something to a map, we can use this and say the null door. Okay, so equals to superior else. Okay, and have a warning. Hold on. Oh, yeah, this is supposed to be a string, not an int. All right, so yeah, that looks fine now. So let's go ahead and print that, and we have an error that says assignment to entry in nil map. Okay, all right, so as you can see, the error says that we are trying to assign a value to a nil map. Okay, so this is because the 0 value of a map is nil. All right, so before we can actually assign this a value, we should create the map using the map function, the make function, sorry. So we can go ahead and instead of declaring that a var, let's just make it directly. Okay, so make, it's gonna be wants a map of key should be of type string and value be of type string, and then we can just use this, don't need to specify the capacity or the length, since all those things will be set for us by the Go compiler. So we can go ahead and run this, and as you can see, our map has been initialized. So let's say we want to print out the value of that. You can also use the indexing operator, the indexing operation on maps. So to do that, we can go ahead and say the key of the element we're looking for and run that. As you can see, that prints out nicely. So another way that we could actually create a map is maybe let's use the package level variable this time, and let's say var clans. Let's use clans, so we can go ahead and let's just not use clans this time. Let's use a different one. So we can say kingdoms, and it's gonna be your map, and it's gonna be a map of string type. So it mustn't always be like this. Okay, it could be the keys might just be a string type and an int type. Okay, so maybe let's try this. So you see, so now can go ahead and make kingdoms, and notice that I removed the dot because we've already cleared the variable up here, so we're just assigning it. All right, so and Go is warning me because of type mismatch. Kingdoms is supposed to be of type map, key string, and value int, but I'm trying to assign that to of a string value, so changing that to int should solve the problem. Okay, so let's change this, say kingdoms, and there should still be a problem because we are assigning it to a value of strings, which is not what we specified up here. We specified that we want it to have a key of strings and a value of integers, and right now that's not what we are doing. Okay, so we'll have to change this to an integer, and we can call that 3. So once we save that, you can see everything works fine, and we'll try to print it, and prints out nicely. Okay, so yeah, basically maps are key value pairs, and you can define many types of so this can actually be ints, and let's use string, so you can actually have any type of key types that you want, and also value types. And we just need to switch this. Let me see if this is going to work. I can call this Ronaldo, and let's see. Everything looks nice. So if we run that, you can see it works well. Okay, so yeah, they're also pretty flexible and makes it very, very easy for you to find things and, you know, save things somewhere. And you can even work as databases if you want to save something in memory and access them, you know, whenever you want, using the key, and, you know, all stuff like that usually works for with maps. Okay, so to get the length of a map, we can still use the same length function that was built in Go, that is built into Go. And yeah, we can also get those values. If you want to delete an element from okay, let me quickly change this to use string of strings. So okay, so I'll call this VNR, and down here I can call this fin dolphin. So call this Teleri. Okay, so we can do that, and, you know, get the length. If we want to delete, let's say we want to delete one of the elements, we can use the delete function, which is also comes built into Go. So let's say we want to delete the first element, so we can just pass in the map and the key. Almost want to delete the Teleri. Run that and try and print out the length again. As you can see, the length was 2, and after the delete method run, we now have function run, we now have just 1. Okay, so yeah, so that's that about maps. And please feel free to go by example. I think they pretty much have some really good resources on maps, and so many of these things that we're teaching to get more experience. Okay, so before we move on to structs, one final way of creating maps, it could be using our colon and equals operator, which could basically, when we can use it basically when we know exactly what we're expecting. So let's redefine the signature of our kingdoms variable, and declare that it should be of key of string, and the value should be of a slice of strings. Okay, so it's also possible that you can use slice as the value of your keys. That also works. So now we'll go ahead. The first thing we'll do, we use the make function to create it. So quickly do that, string, and then it's gonna be slice of string. Okay, okay, something is not right. Oh, this should be map. Okay, so yeah, that's we've created our kingdoms, and we can then go ahead and assign our values to this by doing something like this. Let's say string. So again, Ronaldo, and Fano, then have the Teleri, which is Finware, and yeah, so on and so forth. So what's the problem? Oh, oops. So this should be map string. Yeah. What was the problem this time? Oh, yeah. This is what happens when you're using a static types. So it gives you the flexibility of telling you when you are wrong or when you're doing something totally stupid. So it's, you have to give it exactly what it wants. Yeah. So now this is it's expecting that we give it an array of string, not a string literal. So to change that, can just go ahead and define a string, an array slice. Okay, so this is a slice. Okay, so again, this is like a list. So this is just a list of strings, and it just contains only one element at this time. Okay, so yeah, that all looks fine. We can print that to the command line, fmt eln kingdoms. That should work. Yeah, so yeah, and this is it. Okay, so we can even make this a bit more simpler. We can get rid of these two, get rid of this, get rid of this up here, and then just clear everything as we are going on. And yeah, this is far more faster and straightforward. Okay, so yeah, I think that's that for maps. And the next topic is going to be on structs. All right, so what are structures or structs? So a struct is a data type that aggregates different kinds of data values of different types. Okay, so yeah, a classic example, so you're seeing below, we have a COVID-19 stats that contains different kinds of different values. Okay, so let's go straight to the code so you guys will see how this thing is actually used. And I'm going to copy this over and okay, so okay, so I think I'm going to have to stop this video here, and the part 3 you're going to talk about structs and then move on to our type declarations topics. Okay, see you in the next video.